Welcome to Click Academic. This is lesson 7 on the series of set theory and logic, and we'll be discussing logical equivalence. Remember, we are still under logic. So today we are going to talk about what we mean by logical, when something is said to be logical equivalent. Now, if you remember in our previous class, we have been mentioned logical equivalent. It means that in a logic form, when we say something is logically equivalent, meaning it's what you call in a normal mathematics equal to. But here is because we are dealing with logic operations, so therefore we say that what is in here as the left hand side is logically equivalent to what is in here in your right hand side. So therefore, what do you mean by logic? We now say, okay, a logic is when two or more prepositions are are said to be logically equivalent using these symbols if they have the same truth table. If you remember in our previous class, we must have the column of the truth table, using truth table, the column of this and this, they must be equal before it be logically equivalent, based on the previous class that we did. So now let's take some example and see whether they are logically equivalent. Let's say example 1. We are to test that negation of P and Q and this, which is negation of P or negation of Q, whether are what? This is 1 and the 2 1, which is negation of P or Q and negation of P and negation of Q are what? Are logically equivalent. Now this is the question. So now to test with these two, you know, so okay, let's say 1 using truth table. This is truth table. We have P, Q, right? We now say, okay, what do we mean by what? P and Q. Then negation of P and Q, right? And then what? Negation of P, negation of Q. Then this column is what? Is negation of P or negation of Q. So therefore, this is true, true, false, false, true, false, true, false. Remember, in the case of and conjunction, it's said to be true when all are truth. True, true is what? True. True, true, false. True, false, false. False, false is false, right? Then we are going to use this. We are going to negate this to get this column. Negation of true is what? False. Negation of this is what? True. Negation of this is what? True. Negation of this is what? True. Right? So now the next aspect is this. Negation of P is negation of true is what? False. Negation of this is what? False. Negation of this is what? True. Negation of this is what? True. Then we now negate Q. Negation of T is what? False. True. Then this one is what? False. True. That's where we're negating. Then the relation, this one is O. Remember, O says when at least one is true. False, false is false. True, false is true. Then true, false is true. True, true is true. Now you see we have false, true, true, true. Meaning, if you check this and this, you see we have false, false, true, 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 true. You can say therefore, a negation of P and Q are logically equivalent to what? Negation of P or negation of Q, which is this column, and this column is this. So therefore, this is the way we are proving using logical equivalence, using truth table. So to answer the next question, which says that what? Number 2, we are given what? Negation P O Q and negation of P and negation of Q. Now for us to solve this, we can say, okay, using truth table at the same time, this is P column, this is P, Q, this is P, O, Q, this is what? Negation of P, O, Q, in bracket, then this is what? Then we now say, okay, negation of P, negation of Q, negation of P, and negation of Q. Now this is the table that we're going to do. Let's say we have true, true, false, false, true, false, true, false. So now we are going to start with this O, which is the disjunction. Disjunction says that it's true when at least one value is true. Now true, true, false is true, true, false is true, false, false is false, right? Then we are going to negate the answer. The negation of this is what? False, 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 true, right? Then we now say the negation of this is what? Negation of P. This is true, it will be false. This one it will be false. This one will be true. This one will be true. The negation of this will be what? False will be true. False will be true. If you negate Q, right? Then now remember this is and. And is true when both are true. False, false is false. True, false is false. True, false is false. True, true is what? True. Now, if you check this column and this column, you see that we have false, 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 and true, true, right? So, meaning we can say, therefore, negation of P, O, Q is equivalent or are logically equivalent with negation of P and negation of Q. Now, if you observe this, something occurs. Now, what I'm saying is like, when you look at this, the first answer that we derive from the first question, which is this, which we say the first one, which is negation of P and Q are logically equivalent. That's the first one that we proved, negation of this, and this is the second one that we proved, which is negation of this or negation of this, logically equivalent, negation of P and negation of Q. Now, if you look at this, it means something. If you remember in a set, normal set, under set, De Morgan's law under the set, it says that what? When you have A intersection B, all complement is equal to what? A complement union B complement, right? And then it says that what? When you have A union B, all complement is equal to A complement intersection B complement. Now observe this and this. How can you relate it? Remember, here is complement, here we are using negation. This is and union. You see? So therefore, this is what he called De Morgan's law of logic. These two relations, they are De Morgan's law of logic. So when you are asked to prove this De Morgan law of logic using truth table, this is the example that we solve. That this is the way that you are going to solve this. Thank you very much.